Hello everyone, in this video I am going to tell you about another oxide of carbon, that is the carbon dioxide, which you are quite familiar with. Okay, carbon dioxide, you very well know that it is consumed by the plants and during respiration given out by the human beings as well as animals. Okay, and it is present in atmosphere. Okay, so the what we are going to study in this video is carbon dioxide. The formula you very well know of carbon dioxide, it is CO2. Okay, carbon and dioxygen. Okay, therefore carbon dioxide. Okay, like studying any other compound, we would first see its method of preparation. Okay, so the first heading would be preparation. Okay, how do we prepare carbon dioxide? Although carbon dioxide is present in atmosphere, but if we want to prepare it in laboratory or on a large scale, how do we do that? Okay, so first we would see is lab preparation. How do we prepare carbon dioxide in laboratory? Okay, in lab, if you want to prepare carbon dioxide, we use dilute HCl and calcium carbonate, that is marble. Okay, action of dilute HCl on marble chips. Okay, that is calcium carbonate. So what happens? Calcium carbonate, CaCO3, when reacted with dilute HCl, okay, when reacted with dilute HCl gives CaCl2 plus CO2 plus H2O. This is the reaction. Okay, and thus you prepare carbon dioxide in laboratory. Now if you want to prepare carbon dioxide in bulk, that is industrially. Industrially, how will you prepare? Industrial preparation. Industrially and on a large scale, carbon dioxide is obtained as a byproduct. Okay, carbon dioxide is obtained as a byproduct of two processes: in the manufacture of quicklime and in fermentation. It is obtained as byproduct, that is the secondary product, in manufacture of quicklime, that is calcium oxide, and fermentation. Okay, the reaction goes as follows: CaCO3 solid on heating gives calcium oxide solid, which is quicklime, plus CO2 gas. Okay, and fermentation, like if you ferment glucose, that is C6H12O6. Okay, this is glucose. Okay, on fermentation, it gives ethyl alcohol plus CO2. Okay, so this is how you carbon dioxide is obtained as a byproduct industrially. Okay, now we are gonna see some properties of carbon dioxide. Okay, okay, some properties you very well know. Okay, what is the color of carbon dioxide? Carbon dioxide is colorless because you cannot see it in atmosphere. Although it is present, but you cannot see it. Can you smell carbon dioxide? No, you cannot smell. So it is also odorless. Okay, it is colorless and odorless. Now, what? Now we would see its solubility in water. Carbon dioxide is a heavy gas. Okay, it is a heavy gas and dissolves in equal volume of water. Okay. Okay, but under pressure, that is when we apply pressure, carbon dioxide can readily be absorbed in water. It can easily absorb. Okay, that means that even if the volume of water is less, you can absorb more carbon dioxide in equal volume of water when you apply pressure. Okay, so under pressure, CO2 readily dissolves in water. Now, seeing this statement, can you think one of the very practical application of this statement, which every one of you must be knowing, or by subconsciously must be knowing? This phenomenon is observed in preparation of fuzzy drinks or the cold drinks or the soft drinks which you say. Okay, this phenomenon is observed in preparation of fuzzy drinks or cold drinks. Okay, so what we do, that we take water and we dissolve the sugar and other the adulteratives in that. Now after that, what we do, that we apply pressure and compress and dissolve carbon dioxide in it. Okay, that is why when you open the cold drinks, fizz comes out. It is actually the carbon dioxide which bubbles out of the cold drinks. Okay, which is initially in compressed form. Okay, now going further with the properties, CO2 is easily liquefiable. Okay, you can easily liquefy CO2. Okay, CO2 can be easily liquefied, and a cylinder of this gas is used as, now compressed CO2 or liquefied CO2 can also be used as fire extinguisher. You must have seen this, that we use compressed CO2 as fire extinguisher. Okay, now when you must have heard of dry ice. What is dry ice? Okay, so the next property relates to dry ice. Okay, dry ice, it is that when highly compressed carbon dioxide is allowed to expand, okay, solid carbon dioxide is formed. Okay, that is when highly compressed gas is allowed to expand rapidly solid carbon dioxide is formed. Which is called dry ice. Okay, so what is dry ice? Dry ice is basically solid carbon dioxide. Okay, this is what is dry ice. Now, the next property. We would see some reactions of carbon dioxide. First of all, carbon dioxide is an anhydride of an acid. But just by looking at this, can you think that of which acid it is anhydride of? CO2 is anhydride of H2CO3. Okay, and this is called the carbonic acid. You can very well see that H2O plus CO2, this leads to H2CO3. Okay, or when you remove water from H2CO3, you get CO2. So this is how you remember that. Okay, now it is anhydride. Okay, the next property is it reacts with alkali to form carbonate. Okay, carbon dioxide reacts with alkalis to form carbonates. Okay, this is used as a test for carbon dioxide. Okay, this is used as lime water test. For CO2 gas. Okay, the reaction is as follows. You take an alkali like calcium hydroxide and you react CO2 with it. Okay, then you will get calcium carbonate CaCO3 plus water. Okay, and this is the lime water. Okay, so lime water would be formed which would be milky. Okay, now the above reaction is also responsible for temporary hardness of water. Okay, so you must have studied that there are two types of hardness, temporary hardness and permanent hardness. Temporary hardness can be removed. Okay, hardness is because of the carbonates of calcium and magnesium. Okay, so this reaction also leads to formation of calcium carbonate, okay, which makes water hard, but it can be removed easily. Okay, so that's all for carbon dioxide. We would see some few small compounds, other compounds of carbon. Okay, like one compound is carbon suboxide. Okay, the formula for carbon suboxide is C3O2. Okay, I would just draw the structure of carbon suboxide. Okay, the structure of carbon suboxide is this: C double bond C double bond C double bond O double bond O. For the time being, you just need to remember this. Okay, now the next compound which we will see is carbides. Okay, now carbides. Now there are three types of carbides. Okay, one is ionic carbide. The example is like Al4C3. Sorry. Okay. The next type of carbide is covalent carbide. There are many examples of covalent carbide. Basically, these ionic carbides are ionic in nature because they are formed by reaction of the ionic compounds or the more electropositive compound, okay, that they are which are on the left side of the periodic table with carbon. Covalent carbides, like for the example CH4, CO2, they are formed with the less electropositive compounds, or you may say electrovalent. These are the covalent compounds. Okay. Now the third type of carbide is metallic carbide. Okay. This carbide is formed by when carbon reacts with transition metals. Present in voids of transition metals. Okay, metallic carbides are when carbon is present in voids of transition metals. Okay, now this helps in conduction of electricity. Okay, like some of you must know that some of the transition metal compounds, when carbon is present, they conduct electricity at a very rapid rate. Okay, because of carbon present in the voids. This helps in conduction of electricity. There is another very important compound of carbon, that is silicon carbide, which needs special reference. Silicon carbide, the formula is SiC. Okay, silicon carbide is the most important point regarding silicon carbide is it is used in grinding of wheels. And it is a very strong compound. Okay, it is very strong and it has a diamond-like structure. Silicon carbide is also called corundum. It is also called carborundum. Okay. Silicon carbide is also called carborundum. Okay, and it has a diamond-like structure. And it is a very strong compound. See, diamond again is a very strong compound. Like it is not easily broken. You know that. Now, since silicon carbide also has a diamond-like structure, therefore it is also a very strong compound, and hence it is used for grinding of wheels. Okay. So what did we see in this video? We first saw that the laboratory preparation and the industrial preparation of carbon dioxide. Okay. Then we saw some properties and its applications, that it is used in preparation of fuzzy drinks, as a fire extinguisher. We studied about dry ice, what it is. We see that how do we test for carbon dioxide. Okay. And we saw some small compounds of carbon like carbon suboxide, carbides and silicon carbide and its use. Okay. So that's all regarding the carbon. In the next video I will be beginning with the compounds silicon and its compounds. Okay.